Today is a beautiful day. The sun is shining. The birds are chirping. It's Monday morning. What's the date? Today's date is November 28th. And we have a 9:30 to start our morning off. So if you want to try this at home, if you're sick today and you want to do some work, press pause, try these questions, and then listen to the answers. See if you did okay. Our first question is a rational numbers question. It says the square root of 9/16 plus 400ths. And it says don't use a calculator. So for the first one, you're thinking should be what fraction multiplied by itself give you 9/16, which of course we know is going to be 3/4. So the square root of 9/16 is 3/4. Square root of 4/100ths. If I want to do this without a calculator, I need to think of it as being the square root of 4/100ths, or what fraction multiplied by itself is 4/100, which is going to be 2/10. Now, if you wanted to, what could you reduce that down to? Instead of using 2/10, what could we use? Not all at once. It gets so confusing when you all yell. Instead of saying 2/10, I could say 1/5. So I'm going to actually write it as 1/5 because it's always better to use lowest terms if you can. So we're going to put 1/5 there. So really, this question here, when you simplified both square roots, became this question right here. And that question right there is just a grade 7 question, adding two fractions together. Common denominator will be 20. Equivalent fractions 15/20ths, which is equivalent to 3/4. 4/20ths, which is equivalent to 1/5. Add your numerators, keep your denominator. Your final answer will be 19/20ths. Your second question is also from rational numbers. Negative 4.5 plus 3 times 1.8 says don't use a calculator. So we are going to do bedmass here, which means between the operations of addition and multiplication, we all know by now we're supposed to do multiplication first. 1.8 times 3. If I estimate it, it's going to be 3 times 2, which is going to be 6. So I know my answer is approximately 6, which really does mean I don't even need that decimal. I can drop the decimal and just say, okay, I'm just going to multiply digits together. 8 times 3 is 24. Carry my 2. 3 times 1 is 3, plus 2 is 5. And the only place I can put my decimal to approximate 6 is right here. So therefore, I have negative 4.5 plus 5.4 as my second line of what that is. Now, if I think about what I would do here, I'd actually use estimation. I'd say, let's just use greatest place value, negative 4. That's not rounded to anything, but plus 5. What do I have more of, positives or negatives? I have more positives. The difference between them is really my answer. So what I'm going to do here is I'm going to take what I have more of, in the case of positives, and subtract what I have less of, which is negatives. Borrow, I get 9. I get 0.9. Will those be positives or negatives? They will be positives. Why? Because I have more of them. Therefore, my final answer is 9/10, or 0.9. Positive. Third question comes from our last chapter 3 on exponents. At the top here we have what appears to be something we can simplify with sign rules, but we can't because they're addition. So we're going to simplify these into standard form. That is the opposite of 10 cubed, and 10 cubed is 1,000. So the opposite is negative 1,000. Our next one is negative 10 squared, which is negative 10 times negative 10, which is 100. If you want to keep it in brackets, you can. And our last one is 10 to the exponent of 0, and any base to an exponent of 0 is a standard form of 1, so plus 1. Divided by 10 to the exponent of 1 will be just the number 10. So negative 1,000 plus 100 is going to be negative 900. And negative 900 plus 1 is going to be negative 989 divided by positive 10. So when we simplify that numerator, it's going to be 989, negative 989 divided by 10. When we divide by 10, we don't need to grab a calculator. We simply move our decimal one place over. Our final answer will be negative 98, decimal 9. I'm an idiot. Don't call yourself an idiot, Mr. McDonald. It's negative 900 plus 1 over 10, which is negative 8 99 over 10, which is equal to negative 89.9, and not the other. Thank you, Andrew. Some days, Monday morning, your brain just doesn't work very well. Next question is from rational numbers. The addition or sum of two rational numbers that are in fraction form. The first one's negative, the second one's positive. I'm going to change this to negative 3/4 plus 6/5 to find a common denominator of 20. Equivalent fraction will be negative 15/20. Equivalent fraction will be 24/20. Remember, keep your numerator. Add your denominator. Keep your denominator. See, Monday morning. Keep your denominator. Add your numerators. The final answer will be 9/20 because negative 15 and a positive 24 make a positive 9 over the denominator of. Yes, I could feel the effects of Monday morning. Same question, except for multiplication makes it much easier. Negative 3/4 multiplied by 6/5. Multiply your numerators. Multiply your denominators. Your final answer is negative 18/20. But your teacher would freak out if you kept it in non-lowest terms. In lowest terms, negative 9/10. Now, if you're one of those people who didn't reduce it to lowest terms, just make a note in your paper. Don't forget to look for lowest terms. Is it lowest terms? Can you divide both numerator and denominator by a number? In this case, yes, you can divide them both by 2. Now we're going back to this is actually a grade 8 question because we are dealing with not negative coefficients, but we're dealing with dividing by negative values. So we do have to, grade 7, grade 8 doesn't matter. So it's to solve with opposite operation. Remember in grade 7, this is called your coefficient. This is called your constant. In two-step algebraic equations that have both a coefficient and a constant, the best way to get rid of it is get rid of your constant first by applying opposite operations. I'm going to add 3 to both sides. 2x equals negative 2. Once you have that, you're going to get rid of your coefficient next, which is multiplying. The opposite operation is dividing. Divide both sides by 2. And x will equal negative. If we look at that question from a drawing standpoint or a model, this is the exact same question. It still says 2x minus 3 or negative 3 equals negative 5. It's the same question. What we're going to do first is algebraically apply positive 3 to both sides. We notice that we're keeping equality here because whatever we do to one side, we do this to the other side. We end up with 2x is equal to negative 2. I'm going to take those 2x's and divide them equally onto 2 scales. Divide the other side onto both scales. And we end up with x equals negative 1 as our solution. The next question, solve with opposite operation again. How much of x do I have here? How do I read this term? How do I read that? I could read it as x divided by 3. Or, Gavin, how else could I read that? A third of x. So our coefficient is a third. Our constant is negative 4. So what I'm going to do is I'm going to get rid of my constant by adding 4 to both sides. A third of x is equal to, that is going to equal a positive 3. Now remember, a third of x, I just want to kind of make a note here if you want to have it. A third of x could look like that. A third of x could look like this. Or a third of x could look like this. All 3 of those are a third of x. Okay. But what we're going to do is we're going to multiply by 3 to get rid of the third. Because really, if I think about it, if I multiply this by 3, or triple it, we're going to see in the next question, I'm going to end up with a full x. If I triple this, if I multiply this by 3, the third times 3 becomes 1, or 1x. But either way, I end up with x. But because I multiplied my left by 3, I multiplied my right by 3. Give me a solution of x equals 9. Our last question is the exact same as question 8. It says a third of x. It says a third of x minus 4 equals negative 1. It says the same thing. So we're going to add 3 to both sides, or add 4 to both sides and get rid of the constant. Add 4 to that side in order to keep it balanced. You have to add 4 to this side. A third of x is still equal to what's left over here, which is 3. I'm going to triple both sides. So if I triple the way to this side, I have to triple the way to this side. That is going to end up being a full x equals, and I'm too lazy to do it, so I'm just going to go like this. Therefore, x